Hello, dear students. This is the second part of the lecture of data communication overview, week one, second part. So, in this lecture, we will be familiar with the components of data communication. So, a data communication system has five components in total. So, these components are the message, the sender, the receiver, and also the transmission medium protocol. So these are the five uh, components of data communication. Okay, so in that particular point, when we start about the components of data communication, so we have to know what is the message. Okay, the message is the information to be communicated. Popular forms of information include text, numbers, pictures, audio, video. But in this case, I have to say one thing. Uh, in communication, you need to transmit desired signal. That means the message is the desired signal, and the message should have to be meaningful. And what the particular receiver and uh, consumers and other peoples will take this, how they can take this. Okay, and now in the second part, the sender. The sender is the device that sends the data message. It can be a computer, workstation, telephone, handset, video camera, and so on. These are the things, the devices, whether the modulation came into account. And receiver. The receiver is the device that receives the message. So that can be a computer, workstation, telephone, handset, television, and so on. That's the similar from the sender occasions. And the fourth component, most useful component, without that uh, really nothing could have to be transmitted. So that's the transmission medium. The transmission medium is the physical path by which a message travels from sender to receiver. Some examples of transmission media include twisted pair wire, coaxial cable, fiber optic cable, and radio waves. So transmission medium generally divides into two parts. One is the guided media. You can say the guided medias. That's the guided media. Guided media. Guided media means the waves should have to be guided through some medium. So there is a no media condition too, that is the unguided media. That means the radio waves that has been transmitted through wireless channels. So if it is wired, so that can be considered as guided media. That's the twisted pair, coaxial cable, fiber optic cable, radios, and so on. And the fifth and most important part that data communication deals with, that's the protocol. So is a protocol is a set of rules that govern data communication. So we have to keep on mind what is the basic behind that. Protocol is a set of rules. You have to keep this thing on your mind, that that is the important thing. Protocol is a set of rules that govern data communications. It represents an agreement between the communicating devices. Without a protocol, two devices may be connected but not communicating. Okay, so that's the agreement between the communicating devices. That means there are some set of rules in the sender section, and there are some set of rules in the receiver section. If they both have agreed to this kind of things, they could really communicate to each other. So just as a person speaking French cannot be understood by a person who speaks only Japanese, so they have to have a common platform. That is the protocol. There is a set of rules that govern data communication, which represent agreement between the communicating devices. So that's the important thing. Now, okay. So in total, we get five components of data communication. Apologies. That's the message, sender, receiver, transmission medium, and protocol. Okay, so there are some important things of data representation. What's the data representation? Come on for it. There's a text. The texts are in bit pattern, and these bit patterns are also can be represented by ASCII, extended ASCII, Unicode, ISO, the numbers, the decimal numbers, images divided into matrix or pixels, audio that has been represented by sound or analog and digital signal, and video that is represented by analog and digital signal. So these are the things. And the ASCII is the 128 different symbols with 7 bits, and extended ASCII size of each pattern is 1 byte. So Unicode 65.536 symbols, that is 16 bits. So these are the data representation. Okay. Now we will move forward to our next section, that why we are talking about the data representation in that particular slide. Because if we want to send text, so we have to convert the text into bit patterns, and if we want to make the bit pattern understandable to the devices, so we have to just convert it to the ASCII, extended ASCII, Unicode, ISO, the numbers, these type of things. And in the larger sense, that's the images, audio and video, these are representations of the analog and digital signals. So if it is sound, it will be audio. If it's not sound, it is a sound and a video, it will go to the video. And it is a series of the images, right? So if you go through the images, that will be divided into a matrix of pixels. Okay, now, so what is data flow? Communication between two devices can be simplex, half duplex or full duplex. It's one kind of type that how the data flow goes through to the communication system. Because of the direction of data, that makes the comparison, that makes the type of the data flow. First of all, that is simplex. Simplex means that is an unidirectional communication. That means that have only a way. That means a one-way street. Only one of the two devices on a link can transmit, the other can only receive. It will not transmit. Keyboards, traditional monitors are examples of simplex devices. Some traditional communication devices, they also use some wireless, some walkie-talkie, wireless walkie-talkie device are also the think of a simplex type, when you are just using just one part that has been activated to the another part. So the simplex mode can use the entire capacity of the channel to send data in one direction. So it can use the entire capacity of the data. Okay, so going through to the next slide, that is the half duplex. Half duplex means you would get the chance, give them chance to a certain period of time to use their direction of the data type. As you can see here in half duplex mode, each station can both transmit and receive. They have the ability to transmit and receive. But in the simplex form, if we go through to the simplex form, as you can see here, there is a direction of data, just one direction, unidirectional flow. It's a mainframe to the monitor or keyboard to the monitor, right? Now, when you go through to the half duplex part, you can see that this I have told you before in the walkie-talkies, if we use in one-sided directional, just one-sided communication transmission, that will be the walkie-talkie sides, that if they press one side, that they are transmitting the data. In that particular portion, they will not receive, they will not listen to anything. So the walkie-talkies and CV, citizen band radios are both half duplex systems. The half duplex mode is used in cases where there is no need for communication in both directions at the same time. So that's not at the same time. If it is at the same time, that will be full duplex. We will go through the next slide. The entire capacity of the channel can be utilized for each direction. That can see for a certain period of time one, that is direction of this, certain period of time two, the direction of the another portion. So as we can see the full duplex part, so that is the both communication